Okay, today I'm going to talk about section 4.5, the substitution rule. So this is like outline. I'm going to talk about what is the substitution rule for the indefinite integral. What is the substitution rule for the definite integral? We have two versions. I'm going to give the examples. How to evaluate integral 2x, the square root of 1 plus x squared dx. We cannot use anti-differentiation formulas. We don't have it. So what's like anti-differentiation formulas? Anti-differentiation formulas is integral x to the n dx is 1 over n plus 1 x to the n plus 1, like this, right? We call anti-differentiation formulas from the Kasha's lecture yesterday. So this is like the idea, but we cannot use the anti-differentiation formulas. So we can use the substitution rule. They're like today's title. Suppose that capital F is antiderivative of F. What does it mean? Capital F prime of X is little f of X. This is like a definition of antiderivative. So we think about the derivative of a composite function, capital F of g of x prime. You can use chain rule, the outer function prime, capital F prime of inner function g of x times inner function prime. So what's like a capital F? Only replace. Capital F prime is this one. So we have this kind of things. The next, we can take integral to both sides. So far we have f of g of x times g prime of x equals capital F g of x the whole prime. Exactly, this one equal this part. We can take integral both sides. We can take integral to both sides. Like this. So what happens? Automatically this one is cancelled here. The integral and derivative is cancelled. We have f of g of x plus c, right? Another one. We think about this is like an indefinite integral version. What's like a definite integral version? So we think about definite integral version. So here you can use same things. The f of the g of x times g prime of x is same to the capital F of g of x, the prime, same. You can take integral to both sides, like this. The only difference is you can write lower limit, upper limit. This is like a definite integral version. So what happens? This one is same to like this, same. The integral, the derivative is gone, exactly f of g of x from a to b. So we have this is like this one, yep, that's right. Oh, this is capital F, sorry, this is capital F. This is capital F. So plug b into x, capital F of g of b minus capital F of g of a. So one more. You can change this one to this kind of things. So we can change it. This is same to f of like u from the g of a to g of b. It's like the same things because you plug g of b into u, f of g of b. You plug g of a into u, we have g of a. What's like a capital F? The capital F is exactly antiderivative of f. You can use the integral form, again, integral from the like f of u du. So like this, you can use new lower limit, upper limit, g of a and the g of b. It's like the ideas, right? So what is the substitution rule? I can write here. So we have this one. What is the substitution rule? Here, the function is like this one, is given the integral f of g of x times g prime of x dx is given. So here, the first one, how can you find capital F of g of x plus c? You can use substitution rules. You can substitute inner function g of x by u, like this one. So u equals like inner function g of x. The one more, you can find differential form. The du is g prime of x dx, like a differential form. You have to substitute. The g of x is u into here. We have integral f of u. Next one, g prime of x dx is here, du. We have it. The next, find antiderivative by using anti-differentiation formulas. Find antiderivative capital F of u plus c. The next, change back the g of x into here, f of the g of x plus c. We have it exactly same, right? This is like the indefinite integral version. What's like a definite integral version? So integral from a to b, f of g of x times g prime of x dx is given. The same, you can plug g of x into u into here. The du is g prime of x dx, change same things. F of u, the du. So really be careful, the lower limit, upper limit. In this case, the a and b, depending on x value. This lower limit, upper limit, depending on u value. How can you change u value? You can use the relation u and g of x. You plug a into here. We have g of a. You plug b into here. We have g of b. Yes, we have it. Could you get this one? Do you know? Yes, we have same things. In the top one, how can you simplify? Find antiderivative g of a and the g of b. So you can plug upper limit, lower limit, capital F of g of b minus capital F of g of a. So that's it. Exactly this answer that we have it. This is like a whole idea of the u substitution. So summarize here the same. This one, so like this. Do we have it? The next tip. This is all of the u substitution rules. So next tip, I want to give a lot of examples. You can try to solve together. But here, this is like problems. The first one, integral 2x root 1 minus x squared dx. The b, c, d, e, f, g, h, i. We have a lot of problems here. We can start with the first problem, the a. So this one. So how can you solve? So like this. This one. So problem is integral 2x square root of 1 plus x squared dx. Was it like u substitution? Here, remember? Integral f of g of x times g prime of x dx is given, the u is usually inner function from the composite function. You can use g of x, the du is g prime of x dx. So you can substitute u into here, integral f of u du. This is like idea. You have to decide u. So from here, you can decide what is u. What do you think? Could you write your answer on the chatting board? What do you think? What is it like u? Do you have any idea? What is u? So how can you decide u? This is like idea. What's that? The u is usually here 1 plus x squared or 2x form. Don't use square root of these things because how can you find here? You can decide u equal to g of x in here. Choose g of x. How can you know? So u is right nu or wrong nu. How can you check this kind of things? Take a derivative. The g prime of x is, yes, inside one. The g prime of x is in integral. This is like a good choice. The one example is the without root, only choose inner function 1 plus x squared, like this. You can find du. The du is exactly 1 plus x squared dx. So what's it like du? The du is prime, 1 plus x squared prime dx. 1 prime is 0. X squared prime is 2x dx. What happens? Yes, 2x is inside one. Yes, good choice. Just like idea for deciding u. So next, you can plug. This 1 plus x is 1 plus x squared is like u. You plug into here. Just square root of u. The next 2x dx. 2x dx is here, du. We have it. 2x dx is only du. We have a simple form. This is integral. U to the 1 over 2, change it to the power form, du. You need to find antiderivative, the 1 over 2 plus 1, u to the 1 over 2 plus 1 plus c, exactly the power rule. To simplify, this is 1 over, the 1 over 2 plus 1 is 3 over 2, the u to the 3 over 2 plus c, the next, the flip, the 2/3, u to the 3 over 2 plus c. This is not a final, change back. This u is exactly same to here. 1 plus x squared, change back. The 2/3 plug into here. The 1 plus x squared to the power 3 over 2 plus c. That's it. This is a whole idea for solving first problem. It's good? Does it make sense? Okay, good. So this is like idea. We can do some try to solve more problems. It's very clear. It's very clear. So here, this one. Do we have it? The second problem. So this case is very similar. Though we don't have anti-differentiation formula, though we don't have it, you can use u substitution. What's it like u? U is, what's u? Could you run your answer? Yes, the same problem. You can choose inner function 1 plus x squared. Find du, the same. Du is 1 plus x squared prime dx. So we have the du equals 1 prime 0, x squared prime is 2x, 2x dx. It's a good choice because 2x is here the same. It's a good choice. The next change, integral. This is the square root of 1 plus x squared is here, u. Next, 2x dx is here, exactly du. So one more, do you remember? You can change lower limit, upper limit by using u and x. We can write this function is g of x. You plug 0 into here. The lower limit is g of 0. You plug 1 into here, the g of 1. So this is same to integral. The u, square root of u is u to the 1 over 2 du. Was it like a g of 0 here? G of 0 is, you can calculate. You can plug into here. The 1 plus 0 squared is 1. You can change. This is 1. Was it like a g of 1? The g of 1 is plug 1 into here. 1 plus 1 square is 2. So this is change it to like this. The next one, you can find antiderivative. So what's that? The 1 over 2 plus 1 u to the 1 over 2 plus 1 from 1 to 2. So what's that? This is the 2/3 u to the 3 over 2 from 1 to 2. So like this. So you can plug upper limit into u. So we have 2 over 3, 2 to the 3 over 2, minus 2/3, 1 to the 3 over 2. And simplify. What is the 2 to the 3 over 2? The 2 to the 3 over 2 is, you can change it. This one, do you know this one? Like a to the power m over n is the same to what? The nth root of a to the power m. You can change it. The 3 is 2 cubed. The denominator 2 is going to radical form. The square root of a. Square root of a is 2 root 2. So we have it. So this is same to 2 over 3 times 2 root 2 minus 2 over 3. The 1 to 3 over 2. What's 1 to 3 over 2? Could you run your answer? What's 1 to 3 over 2? Do you know the answer? Yeah, this is 1 times 1. So we have the 2 times 2 is 4 root 2 over 3 minus 2/3. That's it. This is your final answer. So like this. So one more. So if you don't want to change lower limit, upper limit, we have another method. We have to use same problem here. Another method is like this. 2x square root of 1 plus x square form. So you can use same u substitution, exactly same. So we have integral, don't write lower limit, upper limit, don't write, just the square root of u du. You can define antiderivative, integral u to the 1 over 2 du, find antiderivative 1 over 2 plus 1 u to the 1 over 2 plus 1, so like this, keep going. The 2/3 u to the 3 over 2, then next change back. This u is here. 1 plus x squared, plug into here, 2/3, 1 plus x squared to the power 3 over 2. The next, you just only plug lower limit, upper limit later. We have the same answer. This one is, you plug 1 into here, the 2 over 3, 1 plus 1 squared to the power 3 over 2 minus 2/3, 1 plus 0 squared to the power 3 over 2. So this portion is exactly same to here, is right? Exactly same. To simplify, we have it 4 root 2 over 3 minus, so this is a 1, 2, 3 over 2. This portion is exactly same to second part. Answer is 2/3. We have the same answer. It doesn't matter. So if you want to change it, the lower limit, upper limit, always use relation of u and x. So if you don't want to change it, you can keep going, only substitute 1 plus x squared and only plug 0. That's right. So one more. If you change the lower limit, upper limit by using u and the g of x, don't change back to x variable. You have to use exact. Don't change back. That's right. Don't change back. Just like a whole idea for solving the definite integral version. So like this. The next one. Was it like a difference of these two problems? This one has 2x root 1 plus x squared form. This one has only x root 1 plus x squared form. So same. In this case, we don't have anti-differentiation formula. So we don't have it. You have to use u substitution. So what is u? So could you run your answer? What is u of this problem? What is u? Yes, same things. I can just show to you why this is same. 1 plus x squared, find tu. So exactly 1 plus x squared prime dx. So the tu is 2x dx. We have only x. How can you deal with the 2? The not difficult. Only divide by 2 the both sides. This is idea. So this is same to 1 over 2 du equals x dx. So we have this one and change. Integral, the 1 plus x squared is here. We have u. The square root of u, the x dx. X dx is here. Exactly 1 over 2 du. Only difference is like this. Next, take out because this one doesn't have 2. This region only change the x dx form. You can use x dx form. Here we have 2x. So you don't need to divide by 2. Exactly 2x. In this case, we have only x. Always eliminate 2. This is the reason. Does it make sense? So what do you think? Okay. Yeah, depending on the integrand has 2, you don't need. Integrand doesn't have 2, yes, you have to divide by 2. The take out 1 over 2, here, we have, you're welcome, the 1 over 2 integral, the square root of u is u to the 1/2. So like this, same. You have to keep 1 over 2, find antiderivative, 1 over the 1 over 2 plus 1, u to the 1 over 2 plus 1 plus c. This is indefinite integral. The 1 over 2 times the 1 over 2 plus 1 is exactly 1 over 3 over 2. The 2/3, flip 2/3, u to the 3 over 2 plus c. The 2 is crossed out. We have 1/3. U to the 3 over 2 plus c. This is not a final. Change back. This u is here. 1 plus x squared. So change back. So 1/3. 1 plus x squared to the power 3 over 2 plus c. So plus c. Okay, that's it. This is a final answer for solving this problem. So one more. I can change this power a little bit, so like this. In this case, here, x cubed integral x cubed, the square root of 1 plus x squared dx, the same. So we don't have an anti-differentiation formula. You can use u substitution. What's u? So could you run your answer? What is u? What do you think? What is u? Yeah, same things. Yes, 1 plus x squared inner function, the same things. You can find du. This is 1 plus x squared prime dx. So the du is 2x dx, same. The integrand doesn't have 2, only x cubed. We don't have any vector constant, same, divided by 2, so like this. So 1 over 2 du. 1 over 2 du is x dx, so like this. Let me see, we have one trouble here. We have only x dx, but what's that? We have x cubed. How can do that? How can deal with these kind of things? You can just split. X cubed is x squared times x times the square root of 1 plus x squared form. So like this, you can change it. Next, here, 1 plus x squared is exactly you plug. This one, x dx. X dx is here, 1 over 2 du. So my question, how can you deal with x squared? How can change u variable? So like this, you have to keep x squared. No, don't do that. You cannot solve because the variable is like u. No, don't keep x squared. You can change it x squared to function of u. The function of u. How can you change? Do you have any idea? How can you change it x squared to function of u? How can you change? Do you have any idea? How can you change it? This x squared? One idea is here. We have u equals 1 plus x squared. We already have it. U substitution, you can use it here. U equals 1 plus x squared is given. You have to solve this equation for x squared. So only subtract 1. So like this. So what's that? The u minus 1 is x squared. This is idea. So what's it like x squared? X squared is u minus 1 from the original substitution. Only subtract 1 from both sides. So this is u minus 1, like this one. And take out 1 over 2. Take out 1 over 2. Integral u minus 1. The square root of u is u to the 1/2. Next, distribute u to the 1/2. Keep 1 over 2 integral. This power is 1. U to the 1 times u to the 1/2 is 1 plus 1/2, 3 over 2. We have u to the 3 over 2. The minus the 1 times u to the 1/2 is u to the 1/2. du. You have to keep 1 over 2. Next to find antiderivative. Here, 1 over the 3 over 2 plus 1, u to the 3 over 2 plus 1, minus 1 over 2 plus 1, u to the 1 over 2 plus 1, plus c. This is same to 1 over 2. So this one is 1 over 5 over 2. Flip to 5. U to the 5 over 2 minus. Same. 1 over 3 over 2. You have to flip the 2/3. We have 2/3. U to the 3 over 2. Plus c. The next, distribute 1 over 2. 2 is crossed out. Only 1 over 5. U to the 5 over 2. The distribute 1 over 2. 2 is crossed out. Only minus 1/3. U to the 3 over 2. Plus c. The last one, you can change back. Was it like u? The 1 plus x squared. You can plug 1 plus x squared into u. So final answer is 1 over 5. 1 plus x squared to the power 5 over 2 minus 1/3. 1 plus x squared to the power 3 over 2 plus c. So this is the final answer by using u substitution. Okay, so what do you think? So far so good? Does it make sense? Okay, good. The next tip. So we are going to the next problem. This is like procedures like this. The next one. 인에거 0 to pi of 10 cosine 5x dx. So do you know this one? What is integral cosine x dx? Do you know this one? What is cosine x dx? Do you remember? What's integral cosine x dx? If you know answer, could you write your answer on the chatting board, please? Do you know what's cosine? So you don't use dx, only c. Yes. Negative sine of x plus c. You're right. The minus sine of x plus c. This is like exactly the indefinite integral. Is right. Antiderivative. So, but we have one trouble. In this case, we have what? 5x. How can you deal with 5x? You can use u substitution. In this case, the u is 5x. The du is the 5x prime dx. So what's the du? The du is the x prime is 1, 5 dx, one more. What's the coefficient? Coefficient is just 1. We don't have a 5. Same. Divided by 5. So we have 1 over 5 du equals dx. Next, substitute. Integral. As I said before, this is definitely integral. You can change it. This is 5x. The 5x is exactly this one, u. The cosine of u. What's like dx here? Dx is 1 over 5 du. You have 1 over 5 du. The one more. I want to change the lower limit, upper limit by using relation of u and g of x. The g of x is exactly this one. You plug 0 into here, g of 0. You can plug pi of 10 into x, g of pi of 10. The next, only take out 105. 105 integral cosine of u du. The one more. Was it like g of 0? What is g of 0? Could you run your answer on the chatting board? What is g of 0? Yeah, because you plug 0 into this x, the 5 times 0 is exactly 0. The lower limit is 0. What is g of pi of 10? Could you run your answer? What is g of pi of 10? Yeah, pi of 2, thank you. You can plug pi of 10 into this x, same. The 5 times pi of 10. 5 is crossed out, pi of 2. So we have pi over 2. The next, you need to find antiderivative. Integral cosine u du is here, negative sign. So minus 1 over 5 times the negative sine of u from 0 to pi over 2. You can keep negative 1 over 5, negative 1 over 5 sine of u from 0 to pi over 2. So you can plug pi over 2 into here, the negative 1 over 5. So what's that? This is sine of pi over 2. Here. So this is make sense, right? Yep. So plug pi over 2, we have sine pi over 2. Like this, minus negative 105 sine over 0. Like this. Oh, so wait a minute. What's cosine x dx? Sorry, the non-negative sine x. So we have made a mistake. This is what? Really be careful. Positive sign. Integral is different. But here, really be careful. Sine of x prime is cosine of x. So I can change it. Sorry about that. It's a positive. So we made a mistake. Yeah. It's a positive. This is like a positive. Sorry. Sine x prime is cosine of x. Was it like integral cosine? Integral cosine x dx is exactly the positive sine x dx. So really be careful. One more. The cosine x prime is negative sine of x. So what is integral sine x dx? Integral sine x dx is, oh sorry, not dx, the plus c. Here, negative cosine x plus c. So really be careful. The total different. The derivative integral, we have different answers. So really be careful. This is positive. So this is a positive one. This is 105 times, do you know what is sine pi over 2? Do you know what is sine pi over 2? Yeah, 1, thanks. Minus 105 times, what is sine over 0? Sine over 0 is, could you run your answer on the chatting board? What is sine over 0? Oh, sine over 0 is 0. Here, sine over 0 is the 0. So like this. The 105 times 1 is only 105. This is your final answer for solving this problem. Like this. This one. The next here. The same. So we don't have a anti-differentiation formula. You can use U substitution. What is U? What do you think? Could you run your answer? Was it like a U in this case? Yes, inner function sine of x. Inner function, the sine of x is U. Why this is true? You can find du. The du is sine of x prime dx. So we have the du equals sine prime is positive cosine x dx. We have cosine x in integrand. Yes, good choice. The good choice. This is same to integral. The sine x is here. U, you plug into here. The secant square of u. This one. The cosine x dx is here. We have du. You can find integral secant square. Do you remember what is integral secant square? Do you know this kind of things? What's integral secant square of x dx? Yeah, tangent, you're right. The integral secant square is, you're right, tangent of u. The one more, this is indefinite integral, always right, c. Tangent of u plus c. So what's that? This is not a final. Tangent of, we can plug. Was it like u? The u is here. Sine of x here. Sine of x plus c. That's it. This is the final answer of this problem. Like this. The next tip. Integral 0 to pi over 4 dx over cosine square of x square root of 1 plus tangent x. So we have it. So what's that? So we don't have it, the anti-differentiation. You can use U substitution. What's U? Yes, it's good. U is like inner function, 1 plus tangent x. The square root is like outer function. We have 1 plus tangent of x is u. What's like du? Du is 1 plus tangent x prime dx. What is 1 plus tangent prime? Yeah, thank you. Secant square of x. So we have the du is 1 prime is 0. Tangent prime is secant square of x dx. One more. We don't have a secant function, but we have 1 over cosine square. You can change the secant to the cosine function. Secant square of x is the same to 1 over cosine the square of x dx. What's that? This is exactly same to the du equals dx over cosine square of x. So we have it. The next is change 1 over 1 plus tangent x is here, you plug. Here, remaining cosine square of x is this one, dx over cosine square of x is here. We have du. Only du. Like this, the du. So this one is relation is g of x. You plug 0. We have g of 0. You plug a pi over 4 into here. G of pi over 4. So this same to the, let me see, integral. So what's it like g of 0? You can plug 0 into here. You can calculate g of 0. G of 0 is 1 plus tangent of 0. So what is tangent of 0? Do you know that? What's tangent of 0? So could you run your answer on the chatting board? What's tangent of 0? Do you remember? What's tangent of 0? You want to really be careful. The here, we know this kind of things. Tangent of 0 is 0. The tangent of pi of 6 is 1 over root 3. Tangent of pi of 4, we have 1. Tangent of pi of 3, the root 3. Tangent of pi of 2, undefined. You need to know there's a special angle for tangent function. So tangent of 0 is just 0. We have only 1. So this is 1. The g of pi of 4, pi of 4 into x. The g of pi of 4 is 1 plus tangent of pi over 4. The tangent pi over 4 is here, 1. The 1 plus 1 is 2. You can change 2. Here, what's it like this one? Exactly 1 over the square root of u is u to the 1 over 2 du. Change it like this. You can change negative exponent. This is u to the negative 1 over 2 du. You can find antiderivative 1 over the negative 1 over 2 plus 1, u to the negative 1 over 2 plus 1 from 1 to 2. This is the same to the minus 1 over 2 plus 1 is 1 over 2. You can think about reciprocal 2. This is like 2. The u to the 1 half. U to the 1 half is square root of u. Square root of u from 1 to 2. So this is same to plug upper limit like this minus. Plug lower limit, this one. Same to 2 times root 2 minus 2. So we have this answer. Got it? This is like a whole idea for solving G. Here, like this. Oh. The next one, integral sine of square root of x over square root of x dx. So same. We don't have a anti-differentiation. You can use U substitution. What is U? So could you write your answer on the chatting board? What is U? What do you think? What's U? Yes. The sign is out of function. Inside one has root x. We have square root of x. Find du. The du is square root of x dx. Prime, the root x prime. What is root x prime? The root x prime is x to the 1 over 2 prime. You can use a power rule. Yeah, 1 over 2 root x. Yeah, thank you. The 1 over 2 is like down x to the 1 over 2 minus 1. We have 1 over 2, the x to the minus 1 over 2. You can change it back to positive exponent. Keep 1 over 2. Only change x to the minus 1 half. The 1 over x to the 1 over 2. We have 1 over 2 times root x. So we have here, what's it like du? du is 1 over 2 root x dx. This kind of things. One more. Here, root x doesn't have 2. You have to eliminate 2. How can you do that? You multiply the both sides by 2, like this. So we have 2 times du equals 1 over square root of x dx. This one. So you can change it. This is same to what? Sine of the square root of x times 1 over root x dx form. Here, the square root of x is this one, u. Sine of u. The 1 over root x dx is here, exactly 2 du. The next, the take out 2. We have 2 times integral sine of u. u. Do you know what is integral sine of u? Could you run your answer on the chatting board? What's integral sine of u? Be careful here. The sine prime is cosine, integral sine is keep negative. So we have negative 2 times cosine of u plus c. Really be careful. The integral has different sign. The negative 2, you can change back. This u is here, square root of x, the cosine of the square root of x plus c. This is your final answer. So really be careful. I can do write again. Integral sine x dx. What's that? Negative cosine x plus c. Integral cosine x dx is positive sine x plus c. Really be careful. This is totally different. What is sine prime? Sine prime is cosine. But what is cosine prime? Cosine prime is negative sign. We have opposite sign for the integration. So really be careful. Okay. The next one. This one. The same. We don't have an anti-differentiation formula. You can use U substitution. What's it like U substitution? What's U? Do you know what's U? Could you run your answer on the chatting board? What is U? Yeah, same, inner function. The square root is like outer function. 7 plus 2x is inner function. Find du. This one is only 7 plus 2x prime dx. The du is 7 prime 0, 2x prime 2, 2 dx. One more. integrand doesn't have 2, we can divide by 2. So we have 1 over 2 du equals dx. This kind of things. So you can change this integral. The 7 plus 2x is just u. We have the square root of u. Was like dx? The dx is 1 over 2 du. We have it. We have one trouble. How can you change x to the function of u? Do you know how can you change x to the function of u? So don't write this x. That doesn't make sense because the variable is like u. How can you change x to the function of u? Do you have any idea? Could you write your answer on the chatting board? How can you change x to the function of u? Do you have any idea? What do you think? Do you know what is it? How can you change x to the function of u? You can use here, same, original relation. The original relation is the u equals 7 plus 2x. You can solve this equation for x. Subtract 7 from both sides. Exactly, u minus 7 equals 2x. Next, divide by 2. So this one is 2 is crossed out. What is x? X is 1 over 2 times u minus 7. So we have it. So here, what's that? 1 over 2 u minus 7. We have it. Next, you can take out 1 over 2 and the 1 over 2, exactly 1 over 4, integral u minus 7, the u minus 7 times the square root of u is u to the 1/2. This one. The next, distribute u to the 1/2. You can keep 1 over 4, integral u to the power 1 times u to the 1/2. 1 over 2 plus 1 is 3 over 2. We have u to the 3 over 2 minus 7 times u to the 1/2. 7 times u to the 1/2 du. You have to keep 1 over 4. Find antiderivative by using power rule. So we have 1 over the 3 over 2 plus 1 u to the 3 over 2 plus 1 minus keep 7 1 over 2 plus 1 u to the 1 over 2 plus 1 plus c. It's the same to keep 1 over 4. The 3 over 2 plus 1 is 5 over 2. Flip 2 over 5. 2 over 5 u to the 5 over 2. Negative 7 times. This is same. 3 over 2, flip 2 over 3. U to the 3 over 2 plus c. You can distribute 1 over 4. So what happens? The 2 is crossed out. 1 over 2 times 1 over 5 is 1 over 10 u to the 5 over 2 minus. This is 2 is crossed out. Only 2, 7 over 6. We have 7 over 6 u to the 3 over 2 plus c. The next, we can change back. The was like u. U is 7 plus 2x. You plug into u. The final answer is 1 over 10. The 7 plus 2x to the power 5 over 2 minus 7 over 6. 7 plus 2x to the power 3 over 2 plus c. This is like the answer of this equation by using U substitution. one, like this. So we have it. The next part, the integrals of symmetric functions. What's that? Suppose f is continuous on the closed interval -a and a. If f is even function, what's the definition of even function? F of minus x equals f of x. What's like integral from -a to a f of x dx? 2 times integral 0, the integral 2 times integral from 0 to a f of x dx. So if function f is odd function, f of minus x equals minus f of x, was like integral from -a to a f of x dx, always 0. This is like symmetric functions. This makes sense to one now. We think about it. Here, case A, the f is even. F is what? Even function. So what does it mean? The graph of f is always symmetric about y-axis. The symmetric about y-axis. So graph is like this. So we think about one example. F of x equals like x scale form. What's graph? This is always even function. The graph is like this. The parabola. So we can choose the -a and a. So we have this area, this one. What is like this area? This area is integral from -a to a f of x dx is, we can write this area is a. This area is a, exactly a plus a. A plus a is 2 times a. 2 times, how can you find a? Only right hand side is possible. The integral from 0 to a f of x dx. We have, this is one good result, like this. So this is true of even functions. Second case, f is odd function. What's like odd function? The equivalent to the graph of f is symmetric about the origin. Here, symmetric, the symmetric about the origin. The symmetric about the origin. So what does it mean? We have one good example. F of x equals x cubed. You can just sketch the graph. This one. Graph is like this and like this. So you just cut this is -a. This is like a. So what is integral from -a to a f of x dx? This one is find this area, find this area. 2 areas the same because this graph is symmetric about the origin. This area can write a. This area write a. What's that? This area a is the below x-axis keep negative, like this. This a is above x-axis from the right hand side, the plus a. So what's that? This is always 0. This is true, like this, right? This is the one good property of symmetric functions. Like this. So I'm gonna give one example. How can you calculate this one? So very complicated, but we think about, you check. The f of x is, you can check. The f of x is the inside one, the tangent of x over 1 plus x squared plus x to the 6th form. So let me see. The function f of x is the even function or odd function. What do you think? Do you know even function, odd function? What do you think? So do you know answer? The even function or odd function. What do you think? Odd function? You're right. So how can you know that? You can calculate f of minus x. You can plug minus x into here, the x, this one, the tangent of minus x over 1 plus x, minus x. The plus the minus x square plus the minus x to the power 6 and calculate. Here, what's like a tangent function? You can draw the graph tangent function. Tangent function is, this is like vertical asymptote, the pi of 2 and the minus pi of 2. Graph is going up and going down like this one. Always symmetric about the origin, odd function. Tangent function is odd function, take negative sign. This is possible. So power is like even power. The minus x squared is only x squared. The 1 plus, same to the x squared, same. The 6 is even power. So we have plus x to the 6, the same. Same to negative tangent of x over 1 plus x squared plus x to the power 6. Was it like tangent x over 1 plus x squared plus x to the 6? Exactly same to f of x. You can keep negative minus f of x. What does it mean? Exactly odd function. Odd function was the result original. The top one is pi of 2, bottom is minus pi of 2. Exactly negative a of a is the odd function. What is the answer? Answer is always 0. This is whole idea for solving this problem. Okay, so this is like all for today's lecture about the use of substitution. So if you have any question, please write your question on the chatting board. If you don't have any question, you can leave a live session. So thank you for attending my class. So I appreciate that you attend and like participate in my lecture. I appreciate. Okay, I'm waiting. Oh, you're welcome. Yeah.